Hi there, welcome to this tutorial on being able to change recurring decimals into fractions. If we have a look at this, we've got 0.6 recurring here. Now 0.6 we need to remember is the same as 0.666 with this number going on forever. That's what recurring means. Now what we're going to do is a fairly simple method to be able to turn a recurring decimal into a fraction. It involves us setting up this number and letting it be equal to x. So if we let 0.6666 equal x, so we have x equals 0.6 recurring. Now if we times this by 10 so that we had 10x, our digits are going to move to the left. So if you imagine on this one here, if the digits move to the left, we're going to have 6.666 carrying on forever, and with the recurring sign it's just going to be 6.6 recurring. Now what we can do is we can take our original x away from our 10x, which is going to leave us with 9x. If we take the 0.6 recurring away from the 6.6, we're just going to be left with 6. Then what you should be able to see is if I move this 9 over to the other side, I do the opposite to what I was doing on the left, which was multiplying. I'm going to divide by 9 on the other side, which leaves us with x equaling to 6 over 9, or obviously we could simplify that to 2/3. Let's have a look at the second example then. Now this time we've got 0.78 recurring, which is the same as 0.787878 continuing. So what we can see this time is if I then let x equal 0.787878 continuing, or 0.78 with the recurring sign above it, then what I could do is I could multiply it this time by 100x. So 100x is going to shift our digits 2 places to the left, so I'm going to end up with 100x equaling to 78.787878 by moving these digits this way. And in the recurring sign, 100x is going to equal 78.78, all recurring. Now what I could do again is I could take my 1x away, the 0.78 recurring part, to leave me with 99x, and that's just going to equal 78. And then again, if I move the 99 over to the other side, I'm multiplying on this side, I'll be dividing on the other side, I'm going to end up with x equals 78 over 99. We could reduce this again, because I know that 7 and 8, well 7 add 8 is going to give me 15, so I know that 3 goes into that. So I could then do 3 into 78. 3 into 78 goes 26 times, and then 3 into 99 goes 33 times. I need to look to see if I could reduce that any further. I can't, so my final answer is 26 over 33. Okay, now if we look at this third example here, we've got 0.37 with just the 7 recurring. Now when I'm doing one like this, I like to write it as the actual number, so I write 0.37 7, 7 to show that this 7 is the one that's recurring and not the 3. Now when we do this, what we need to try and get is we need to try and get this so we've got the 0.777 on its own, so that we can take that away from our other answer. So here what we're going to do is we're going to times this first of all by 10. So I'm going to say 10x is going to equal 3.7777, continuing. Now what I could do now is, if I multiply this now by this original by 100, then 100x is going to give me 37.7777 recurring. Now what I've got, you see, is I've got the 0.77 and the 0.77 in both of these expressions here. So what I could then do is I could say, well, 100x take away the 10x is going to leave me with just 90x. And if I take 3.777 recurring away from 37.777 recurring, I'm going to be left with 34. Now I can just move the 90 to the other side and divide, which leaves me with x equals 34 over 90, which I could then simplify to 17 over 45. I know that won't simplify anymore because 17 is a prime number. And now the last example, example 4. Again, we've got this situation where it is just the 0.18 that is recurring, hence the 2 dots over the 1 and the 8. So that's going to be the same as writing 0.2181818, continuing on. Now remember what I said for example 3, we want to get it so we've just got the 0.18 after the decimal point. So what I could do first of all here, I can multiply this again by 10x. So 10x is going to give me, shifting the digits one place to the left, 2.181818, continuing on. If I then multiply it this time by 100, like I did last time, let's see what we get. If I multiply it by 100, I'm moving the digits 2 places to the left. So I get 21.81818 recurring. Now you'll see we've got a slight problem here, because I can't take the 10x away from the 100x now, because if we have a look, the number after the decimal points here, they're different. We've got 0.181818, but on this one we've got 0.818181. So we can't multiply this by 100. But look what happens if we multiply it by 1000 this time. 1000x is going to move our digits 3 places to the left. So I'm going to have 218.1818, continuing on. Now if you look, we've got the 0.18 in both of these, in the 10x and the 1000x, after the decimal point. So now I can subtract them. So if I have 1000x take away 10x, I'm going to be left with 990x. So if I then take the 2.1818 away from the 218, that's going to leave me with 990x is going to equal 216. Then I can move the 990 over to give me 216 over 990. I could divide that by 3. So 3 is going to go into the top one 72 times, and into 990, that's going to go 330 times. I could reduce that again. 3 goes into both of those. 3 into the top one goes 24 times. And 3 into the bottom one goes 110 times. But of course this can continue reducing to 12 over 55.